All right, so to do the linear approximation, what we're going to do is we're going to use the following formula. So we're going to substitute in some value a into our function, and we're going to add that with the derivative with the same a value plugged in multiplied by x minus a. Okay, so I need a few pieces to make this work. So one of the things I need to know is my derivative. Well, we know that this is the same thing as x to the 1/2. So then if I were to take the derivative of f, I'm going to get not negative, 1/2 x to the negative 1/2. Okay, so I can write that as 1/2 squared of x. Okay, and the other thing I need to know is the value of a when plugged into my original function. So in this case, our a is when x is 1. So when x is 1, the square root of 1 is just going to be 1. And we are going to plug into my derivative. Which is going to give me 1/2. Okay, so now I'm ready to plug in. So I'm going to go ahead and say that my linear approximation function is 1 plus 1/2 times x minus 1. All right, so I can distribute that. So I'm going to get 1 plus 1/2 x minus 1/2. All right, so I'm going to combine my like terms, which that's going to give me 1/2 x plus 1/2. And if I wanted to factor out a 1/2, I could definitely do that. Just a little bit prettier to look at. Okay, so to approximate the value of f at 1.1, we're going to go ahead and plug in 1.1 to my linear approximation formula. Okay, so if you do that, you will get 1.05. And if you check this, if you plug into your calculator, so if I do the square root of 1.1 in my calculator, I'm going to get 1.0488. So I did a good job. Yay. This is good because we're going to know that our linear approximation is good. So now we're going to see a second example where it is not good, and we're going to have to pick a different a value. Okay, so I'm still going to be using the same formula from the previous example. One half x plus 1. So I'm going to plug in 0.1. Okay, and I'm getting 0.55. Now I'm going to do my check. So my check is I'm going to do the square root of 0.1. And I'm getting 0.316. Oh, that was really bad. Hold on, let's fix that. Okay, so obviously these two numbers are not, I mean, they're close to each other, but they're not close enough that I would bet my money on that, okay? So what we need to do is we need to pick a value for A that is really close to 0.1. Okay, so I know that 0.1 is essentially like 10%. So it's like 10 out of 100, right? So I'm going to pick the value of 9 out of 100. So 0.09. Okay. And now you might be asking yourself, well, Ms. Mack, how do you know to pick that? And it's just, it comes with practice. And is that the only number that I could pick? No, but it's really close to 0.1, so let's do that. Okay, so we are going to plug into our linear approximation formula. Okay, so when we are plugging into the original function, that is the square root of x. So I'm going to have the square root of 9 over 100, because that's my a value I'm picking. And then the derivative of that is going to be 1 over 2, because the 1/2, and then you end up with a negative, and we're going to drop that negative down. And that is multiplied by 1/10 minus 9 over 100. Oop. Okay, so I'm going to end up, this is 3/10. This is going to reduce to 10 over 6. And we get 1 over 100 in my parentheses. And if you do all of that, you should get about 19 over 60. Which, if you look at the decimal of that, that is approximately 0.3162. Okay.